Hey everyone, this is the Little Hill. It's MC here. So I am going to be bringing you the game TIS-100. It's a new game out by Zachtronics, and I just heard about it on Monday. And as soon as I heard about it, I just knew that I had to play through this, and I really want to share it with you guys. Um, so I've only watched about 5 to 10 minutes of gameplay. I haven't actually played it myself, so this is going to be a first impression as well from me. Um, but I absolutely love assembly language, programming, stuff like that. I think it's really cool, the math and stuff involved, and so I was so psyched about this game. I hope you guys are excited too. Um, I am planning on going through this at a slow pace, explaining absolutely everything as I go through, and hopefully maybe throwing some interesting tidbits in there as I go along. I think that you can learn a lot, even if you don't consider yourself a programming person or somebody who really knows about these kinds of things. I'm really going to try to bring you along for the ride and explain these things because this is, one of my passions, and I'd love to share it with other people. Um, so I will do my best to explain absolutely everything that's going on. So TIS-100, uh, there is a PDF that comes with the game when you buy it, and it's supposed to be a reference manual for this computer, which is what this game is about. This game is supposed to simulate the microarchitecture of the TIS-100 computer system. And so this reference manual, well, actually, the first page of the PDF is a note from your aunt saying that uh, your uncle has just passed away, and so she has given you his computer, and she just is hoping that maybe you can figure it out, because to her it's just junk. Um, but as with most, if not all, Zachtronic games, uh, there's a little bit of a nefarious undertone with some of the lines in the manual, so it's going to be interesting to see how the story of this one plays out. I've played through Space Chem. I really like that one. Um, and so I'm looking forward to getting into this game. So, one last thing before we start. Um, you can see over here in the left, there is a cycle count statistics, node count statistics, and instruction count statistics. If you've played Zachtronic games before, like Space Chem, you'll probably recognize these. If you haven't, don't worry. So basically, the way this computer works is that it steps through instructions. So each step is considered a cycle. And the number of cycles it takes to complete the program is your cycle count. So this is basically how many cycle counts it has taken almost everybody to do it. I mean, you can't see any other bumps, so everybody's gotten it done, or at least, the vast majority have gotten it done that number of cycle counts. Now, there's a certain number of nodes that will show up on the screen, and you'll see those in just a minute. And so however many nodes you use goes into your node count. And then lastly, your instruction count is the number of instructions you have to write to complete the challenge. So I'm going to try to do my best to get the lowest scores on all of these that I can. But something interesting that you run into, and I ran into this with Space Chem, and I'm pretty sure I'll run into it with this game, is that sometimes you have to choose between whether you want your cycle count to be the lowest, node count to be the lowest, instruction count to be the lowest, or some combination, there between the three. Because sometimes going for the least nodes isn't going to lend itself to the fastest times or the least amount of instructions. But you'll see that as we go along. So anyway, where it's applicable, I'm going to try to create a program for each one of these challenges that does the least number of cycles, does the least number of nodes, and does the least number of instructions. And so we'll see how successful I am. Anyway, without further ado, let's jump into this first one. Okay, so you can see up here in the top left is our instructions for what we're supposed to do for the program. Read a value from in.x and write the value to out.x. Read a value from in.a, write the value to out.a. So you can say in.x right here, out.x right there, in.a right there, out.a right there. And on the left side of the screen, you can see in.x, in.a. And then you can see out.x, out.a. Our output in out.x should match everything down here. And our output for A should match everything down this line. So that's how we know that it's running correctly. So if we just run this right now, we'll see that the left side runs perfectly fine. Out.x gets all the values that are necessary. However, out.a is not receiving any values right now because it's not hooked up. So let's hook it up. We will type in, so you can see over here the way that the left side is working, and we're just going to basically copy this code to the right side to mirror the functionality. Move up, down. So it's taking whatever is in the top of this block and moving it down. And so this next one, move up, down, takes whatever it receives in the top and moves it down. And finally, move up, down, it receives from the top of the block and moves it to the bottom of the block. So the way this move instruction works is whenever something is trying to feed it from the port, the source port, it will pull from that port, and then it will feed whatever it read from the source port to the destination port. Now, if nothing were being put in to the up port, then this would be blocked. That means it would just be stuck on this instruction, and it would wait there until something was given into the up or top port. So that's something we're going to have to be careful about later. It's not going to be too much of a problem early on, but we'll definitely see that coming into play. So if we move over to the right side, we can type in move up, and you'll see that there's a red block right here. So we can't go through that red block. Instead, we have to go left. So instead, we'll type move up, left. Now, this left block is going to be receiving instructions from this right block, so we want to move it, move, and we're going to be receiving from the right, and we want to move it down. All right, now, same thing here, move, up, down. Here, move, up, and instead of moving it down, we're going to move it right. And then finally, move left, down. Now, this should perfectly execute if we did everything correctly, and we can check that out in just a second. But I want to say this first. In some of these challenges, if not all of them, you might see a debug button on some of these red nodes, and that's going to contain a little flavor text, a little story to go along with this game. So let's open it up and find out what's inside. Computer Node Diagnostic, Microcode Dump, 1C15-SA.64. Can't find a pen right now, so I'm just going to take notes here. Looks like short-term storage. 5/10/79, so that's May 10th, 79, I guess. If this is an American writing this. Got this one at the swap meet today. Fellow wanted $450 for it, but I talked him down to $200, so I guess it is an American. Good deal. No idea who makes this thing. Never heard of the TIS series, and the architecture doesn't look like anything I've seen before. Ask the guys down at the 151.N31000, but no joy. Randy has a mystery on his hands. So I'm guessing there's going to be some corruption in these flavor texts, and it's going to prevent us from getting the full idea right away. So that's kind of fun. We'll have to see where this goes. Anyway, back to our program. Let's watch it execute. Oh, and one last thing. If we want, we can step through and watch our program execute one instruction at a time. So you'll see the current instruction that it's trying to execute gets highlighted. So move up, down is highlighted because that's the current instruction trying to operate. move up down has a question mark right here because it is currently looking for a value, but it's not being fed anything. So that's blocked right there. But you can see up here at the top, this first block is receiving an 80. So that is going to get fed down in one step, and we'll see that. And over here we can see 54 getting fed in. Now if we look over to the left, in 80, in 54, and we're going to hope that that 80 gets to the out and the 54 gets to the out. So let's watch it go through. Boom, the 80 hit the out, and so on the next step we should see the 80 appear right here in the output. And there it is. And then we can watch the 54 come out. The 54 is right there. Now because our right side is 2 blocks longer, it'll take 2 instructions more than the left side to execute. Also, you'll notice that it doesn't move a number every cycle. That's because it moves it in one cycle from up, and in the next cycle it places it in down. So that's why you see us skipping an arrow right there. So that move up is not currently blocked, you'll notice, because it's in the process of moving this 54 down, and this is trying to read it. So instead of stepping through this, we can just run it, and it goes all the way through. Look at that. So we were able to complete this in 83 cycles, 8 nodes, and 8 instructions. And that is the least we could do on any of those. Obviously, with the nodes, you can see with the shortest path it would take to get to the output. That is, I believe, almost always going to be the least number of nodes you can use. And then instructions and cycles, that's a little bit more questionable. So anyway, before we leave this program, if we want, we can name it. So the way we do that is we do a comment, which is right there, a £, and we could just write a comment. This is a comment, or we could title it. And so our title could be something like first program. All right, so if we stop, if we press escape, we can return to the segment list, and we can see first program right there, 83 cycles, 8 nodes, 8 instructions. So thank you guys for watching. That was the first challenge. Hopefully we're going to be able to move through maybe 2 or 3 of these each episode after this. But I think that was a pretty good little introduction, and we'll go through more of the instructions as we go along. But that was just a little taste of it, and I hope you guys liked it. Thanks so much for watching. See you next time. Bye.